Hello everyone, welcome to the community updates of Electronic Let's Play. Today we will explore some news from the community, and as per usual, let's start with my ham radio endeavors. So a lot of the parts arrived, and I also got Nano VNA arrived. We might play on the streams a little bit with this. It is really nice tool to measure antennas. It has Smith charts and SWR indication, so this will be fun to play with. Then we have, this is not in the right order here. There we go. The MCHF QRP radio that I'm still waiting for this to be released. Yeah, Smith charts are great, and it is black magic. But the basics I think are understandable. There are really good YouTube videos about Smith charts where it's like breaking down to the basics that you need to use it as just a basic tool, which is nice without going too much into the esoteric graybeard wizard putting smoke into chips level. So yeah, I'm still waiting for the MCHF to become available to purchase, and I hope to get that very soon. The interesting thing that I'm finding out, there's a lot of mods for the MCHF, so I am looking forward to do some modifications like increasing the size of the LCD at some point, so there might be another additional interesting content we can do regarding ham radio, and also crossover to electronics and adaptation, maybe even FPGAs. So I'm really looking forward to that. Then also part of the ham radio related stuff, we were talking on Discord a little bit about new radios coming out, and they had very nice enclosure, which is made out of billet aluminum milled, which I really like as an aesthetic. So I was interested how my existing Baofeng radios that I have here, this is really cheap radios that you can just buy on Amazon. They are like $20–25. So I thought, it's like, how is this built? Can we just could we make a new enclosure for it, or how are they doing the RF section of this? So I wrote an article, I tore it down, I made some photos and posted it on our forum, so you might want to check this out. This looks very interesting. I found a few interesting things regarding how it is built. It uses COB, so chip on board design, but it also uses this very cool stuff that a lot of RF stuff uses, these compartments, usually on expensive gear. This is aluminum milled, and here it is actually essentially injection molded metal. So this is pretty cool considering the price of that device, that they still use this kind of technology, and that they can do high quantity and low cost designs for RF doing this kind of stuff. And also a lot of very good awesome goodies in RF, and see those really tiny coils that are wound here. This is so cool. And so yeah, and maybe check that out if you have some comments, if you have some questions. After I posted this, White Quark made me aware that she dumped the voice chip data out of this radio, and I'm not really planning to do further reverse engineering of it at the moment, but it's good to know that this data is already available, and we can start maybe at some point write a better firmware for this. Maybe someone builds an open source radio and there will be a firmware replacement for this, because this is arguably quite a convoluted firmware and really hard to operate on those Baofengs. But anyways, that's a thing. If you have spare time, you could play with this kind of stuff. But yeah, I found this interesting, so there you go. Then last week was quite interesting. There was also this challenge. So last weekend was DEFCON, and we would be in Vegas now, but because of the situation, we stayed at home. and DEFCON went safe mode, as they call it. So we had all the challenges, all the workshops, like a lot of talks were still happening, but they happened on Discord in streams. And as I told you before, I am part of this team that is for Hackaday. So this was a challenge posted by U.S. Air Force and I think communication security of the U.S. government. But the nice thing is all the data is being released public domain and all the documentation is released. So it is not like they are sourcing the data just for themselves. It is they're trying to just engage people and make this an interesting challenge. So we did the I got invited to be part of this team. Thank you, Will Karuna. And we, thanks to people like Mike Walters and Schneider from Germany and Zach and some other really smart people, we qualified. And this time this was the finals and we took part. The problem was this challenge, the second part, was built very differently than the previous one, and it was much more linear. Much harder for multiple people to work on different things, and so I blame it on the structure of the challenge that we didn't score as well as we did in the classification or the so what happened is we did get 8 points. It's not very much, but it was still a lot of fun. We learned some things. Also, it required you to learn a lot of domain-specific knowledge about how to use the software that you run satellites with and control satellites with. And this is, I didn't have time to put in weeks of effort to learn these tools beforehand, and this was pretty much true for most of our members, which have their day jobs, they have their own lives, and they can take off a weekend, but they cannot take off weeks to prepare for such a challenge. So we had only a few people that were able to actually do some significant work on a lot of this stuff. And we still were the second team to submit a solution for and accepted the solution for the on-orbit challenge, which means we would be able to upload a mission plan to an actual CubeSat. And this was the second most accurate one, and the most accurate one was from the Polish team. Poland can go to space, I think that's the name of that team, which is very nice. It makes me very happy that my fellow Poles scored so well. It does fill me with pride to a degree. So yeah, this was very nice. They did get their code uploaded. The cool story about this, they had I think a storm or something where they were located, and they lost power. So they were running from a diesel generator to be able to power their satellite, the flatsat that they got. So not only solving problems of the challenge, but also problem solvers of real life where they were, which was very impressive. Anyway, so that was Hackaday. It was very interesting. I wish I could have done more, but it was very fascinating to watch other people compete and click into the Discord voice chats and listen to people work on things and see their streams. I, again, was very, very impressed with how great Discord is for collaboration work, where you can have multiple people in text as well as in voice and sharing their screen and having multiple people working on stuff and collaborate as if they were in the same room using the tools available in Discord. So I am even more a fan of Discord than I was before. It is really a powerful tool for collaboration. And yeah, as I said before, we should eventually do some project meetups in our Discord on the 1-Bit Squared Discord. Anyways, next, let's go to Glasgow updates. Glasgow is still in the works. Last week was pretty busy with other stuff, so I didn't get too much done on there, but we did sort out the to-do list, and we pinned down how we want to solve the last few things, like the reset button to do an emergency stop on the Glasgow. So that will be happening, and what exactly capacitor to replace with. So we might actually work on that later today if there is still time after I'm done with the current project that we want to finalize in the main section of this stream. Then 1BitC, there is no really, or IceBitC, there is not really much news. Jordi was gone and was busy with his own things, and I hope maybe this week there will be a little bit more progress. But I hope to get them back in stock very soon. Tigard, we did a lot of testing on Tigard, and this is this guy. So Tigard is still on crowd supply, and we have done a lot of minute testing that the Flash programming in circuit works properly. I did test it on the IceBitC to make sure that I can program the Flash in circuit using Flash ROM. This worked. It was causing some problems earlier, but I figured out that it is the SOI clip, which is not great, and that solved that issue. Then we got also ICE programming, so ICE FPGA programming features in, so we have additional wires for that communication, so that is also fixed. So we are getting that feature built into Tigard, into the final version. So this is getting very, very close to launch too. Then we have Hackaday RemoteCon. So after last stream, I got informed this is still ongoing, and they are still looking for submissions, as far as I understand, for workshops. And Sophie informed me that there will be no talks. So Hackaday RemoteCon will be just workshops and in-person stuff and like chats, I think. But there will be no talks, which I got informed about. So there will be no call for proposals for talks, unfortunately. So just I wanted to clarify that. Then another great news is Chris Gamble. As you know, Chris Gamble is running has a podcast, and as you might know, I'm not a huge fan of Dave Jones, but he started his own podcast, and that is very exciting. Contextual Electronics Podcast. You should check it out. He is venturing out and creating his own content. And this is very interesting. There are already 3 episodes out there. Definitely listen to the interview with Sophie Wong. She's an amazing artist and creator. I met her a few times. You definitely should check this out. And Sophie, he did a good job interviewing her and her talking about how she uses technology in her creations. And so this podcast is definitely to be recommended. All right, so next up, Tanud, or Scott Sharkroft. He is, so as you might know, he is the maintainer of CircuitPython, and he works for Adafruit, and he is working on his own time on exploring FPGA. So he got interested in this whole FPGA stuff, especially because of the open source tools. And so he took the Lambda SoC, which is based on nMigen, and he is making his own modifications to get it to a more accessible platform. So his approach is to find a low-cost FPGA. So he's trying to target the MachXO, which is not supported by the open tools yet, but it is in process, it is being worked on, and eventually will be added. But the advantage of these MachXOs are they are very low cost. They are small FPGAs, but they also are they only need 1 power supply, 3.3 volt power supply. So he wants to make basically small dedicated chips that are, for example, I2C interface or SPI interface, and you load your own designs in there to make translator chips, for example, WS2812 to SPI or I2C adapter chips. And so that is his approach on the system on chips without even a processor in it, and have a wishbone connection from one to other. So you should definitely check it out. He is making, he does streams on Adafruit every, I think, Thursday. And so you should definitely check out, it is being announced on the Adafruit Twitter, if this loads. Yeah, so this was the last stream, and he was talking, oh, Friday, I'm sorry. Okay, thank you. So this was probably an off-date stream. But anyways, it depends probably where you are located, what this time is. So it is 2 p.m. Pacific on Thursdays. I see. Okay, thank you for clarifying. So yeah, usually on Fridays. So look out for his streams. He does talk about his FPGA endeavors a bit earlier in his stream, so the first thing, and then he goes into the deep dive into the CircuitPython for microcontroller related stuff. I think last week he was talking about ESP32 related stuff. No, there is not an open toolchain for Mahexo, but it is in the works. That's the point. The point is it currently doesn't exist, or there is work. It is part of Project Trellis, and there is already a big branch created by CR1901. I think that's his nickname, if I remember correctly. And he's working on adding support for Mahexo. It is not finished yet. It is missing a lot of features. But that said, so after you check out what Tanut is doing, you definitely should check out this branch by, oh yeah, I should have opened this up. I should have looked it up. But anyways, there is a branch on Project Trellis, and CR1901, he's asking people to, if they are making designs with the Mahexo, or using the commercial tools, save the bit streams and save your Verilog so that, and share it with him so he can see which parts are still missing in his implementation, so that he can add the missing features necessary to support the Mahexo with the open source tools. That's the point here. He's interested in input, so you should definitely follow up with him. But anyways, that is what Scott is working on, and I find that interesting. I also sent him one of the Icebreaker Bitsies. He has one of them, so I am hoping that CircuitPython or his system on chip designs will also work on the Icebreaker Bitsie. And that would be very exciting, because then you get a full Python, and this is all built in Python. So you have this nice moldable system, and he is definitely a very experienced Pythonista. And so he's making it very Python idiomatic to create those designs. And he is also approaching it to make it similar to CircuitPython, how the drivers are built in there. So the hardware side of things is similarly built as drivers are for microcontrollers in CircuitPython, which is an interesting thing to do. And so if you like CircuitPython, you should definitely check that out. All right. So not fully last. It's like I know there is something from Rachel Digmon. So, but first we have Dan Rodriguez. He, as you know, he's working on his retro-inspired game console design, which is the IP core for FPGAs that is inspired by SNES and other consoles from the 8-bit and 16-bit era. So definitely check him out on Twitter. But he asked me to share the news that he also got a ULX now. So the design that he made for the Icebreaker also now works on the ULX. Also, he is working on audio stuff. So that is related to what we are doing later in the stream, the gamepad and audio PMod. So he can now generate audio, and he has the ADPCM decoder and mixer and 16 voices, and it now runs on the ULX, but he's planning to compress it down and optimize it to bring it back to the Icebreaker. So his design is meant to run on the small ICE40. He's now using the ULX to quickly iterate over the design, and then after that is where he likes to have it. He will be backporting it to the ICE40, where he needs to do the additional optimization steps. So that is a very interesting thing. He also sent me this little description. It is my take on the programmable ADPCM player, bit like the SNES and Yamaha 90s sound chips. The demo can be tried by whoever has a ULX 3S, but the original intent is to run it on the Icebreaker, hence those design goals in the README MD. Focus on the Fmax and features to make ULX, make it up 5K friendly. So this is definitely happening. And so this is very interesting. You should check it out. And he has this repository here where you can take a look at his audio design for the ULX and then eventually for the Icebreaker. So yeah. Now, Digmon, you had something that you were working on Saturday. So maybe you drop it into the chat here. So I mentioned her streams on the last community updates, and Rachel made a lot of updates, and she got the keyboard to work, and now it is actually lighting up and it is all colorful and beautiful. So maybe if you are interested, go on her Twitch and check out the VOD from last Saturday. And that was very interesting because there was still some shorts and weird endeavors and trouble with software. And then eventually it started to blink, which is very, very exciting every time when you get to the blinky stuff. So as far as I understand, the repository got updated quite a lot. There is a bootloader now and a lot of software shared. Firmware, yes, so the firmware is now there. This wasn't there the last time we talked. All right, so check out Digmon's project and her keyboard. And otherwise, I think that would be it for the updates for this week. And I see you next week. Have a good one. Bye.